Welcome to this presentation of Answer and Meta for CFD What's New in version 25. First and foremost, we have a completely new graphical user interface. So we say goodbye to the old Answer GUI that has been with us for around 30 years with a few minor facelifts, and we introduce something completely fresh and new. This was aimed so as to improve the aesthetics of the software and make it more appealing to new users, but also to provide more space for new functionality that we keep adding with every new version. To make the Answer GUI have a consistent interface with Meta, so as to improve productivity of users, and also to place all the hidden user script functions that we had in the CFD layout onto the main interface of Answer. As always, we recommend that you use Answer in the CFD layout from the launcher. Then the user can go to the CFD meshing profile function here at the top and select the details of the solver, the model, some dimensions, so that Answer customizes in advance all the settings and mesh parameters. Now let's have an overview of the GUI. First of all, at the top we have the so-called ribbon area that we will explain in detail. On the left, we have a vertical toolbar with quick access to all the lists and useful tools like the model browser, the feature manager, batch mesh property list, and so on. The user can access more lists by pressing this button here, so you can get access to more lists and actually pin them on the toolbar if needed. At the top we have the quick access menu with access to useful functions like undo, measure, transform, cut plane, checks, and so on. Here on the right we have access to global settings and mesh settings. At the bottom the interface looks very similar to the previous one. On the left we have the Answer info window, selection assistant, focus commands, drawing styles as before. For the selection assistant, we have added more options, so there are more options to select either PID, PID region, macros, draw mode, and so on. More options for feature angle selection, as to stop or not on PID boundaries or triple bounds. More options for selections like the brush tool, and additional options for box type or circular selection, and so on. Moving to the top ribbon area, you can see that there are tabs for different ribbons, and here there is a 3-dot icon that gives you access to more menus, as some of them may not be active, like for example the Kinetics or the SPH solver, so you can access its ribbon from here. A very useful functionality: the search engine on the top right. So, if you want to find a function but you don't know where it is, you can simply type its name here. Answer will automatically auto-complete the name, and once you select it, Answer will point you at its exact location. If you want to access help, you can press Ctrl and left mouse button on any function. This will open the online help, and you can see an HTML help documentation for this function. Here on the right you have access to the documentation index, video tutorials, and access to contact us for any assistance. Let's see how the old GUI maps to the new one. So, in the old GUI we had the topo, mesh, and deck menus. The old topo menu is now mapped to the so-called geometry ribbon. Here you have access to all the functionality to create and edit geometry. Have in mind that now when we refer to geometry, we imply both CAD data and tessellated data. So, all these functions are applicable to both CAD geometry and mesh, either if it is an STL mesh or a previous mesh. We have groups of functions for specific tasks, like for example to clean up, to design, to create new geometry, to edit tools and setup. We also have a toolbar ribbon called Sketch 3D, which is used to create 3D curves. Again, you can design, edit, and have tools for curves. In addition, there is a button here called Sketch 2D, which gives you access to a completely new ribbon for parametric 2D curve design. Here the user can specify and generate curves, create constraints, parameters, a full parametric 2D CAD system. Whenever you see an arrow button here for a group, it means that there are more hidden functions within that group, so you can access more functionality in each group. But of course, we have placed the most common functions at top level. Moving on to Mesh menu, in the old GUI we had a menu for surface and volume mesh. This has been mapped into two ribbons, surface mesh and volume mesh, each one again split it in groups of functions for specific actions. The old CFD deck menu, where the user could specify things like size boxes and some solver controls, now maps to a completely new CFD ribbon, again with functionality about the mesh, the boundary conditions, the results handling, and the solver setup. The old Morph menu maps into the two ribbons. One is for direct morphing without boxes, and one is for box morphing with boxes. And the old Hexablock menu now maps to a new ribbon, Hexablock, with all the corresponding groups of functions. The philosophy is still the same, so the same actions are done and more or less the same grouping of function is maintained. Now let's move to actual new functionality, starting with surface meshing. In CFD batch meshing, we have added a new parameter that allows curvature refinement with anisotropy, so the user can specify an anisotropic aspect ratio and then Answer will resolve the same curvature with the same curvature distortion, but using anisotropic mesh. This is very easy to use. There is no need for specification of size rules. It's just a setting of anisotropic aspect. And it's very useful because it can actually reduce the total element count while maintaining the same curvature resolution. In batch meshing, we have added an option for right-click scale so the user can select sessions, scenarios, and so on and right-click and apply a scale factor to all the length values in order to coarsen or refine an existing mesh setup. In the past, this was done with a user script function. For batch mesh parameters, we have merged the mesh parameters and the quality criteria in one card with different tabs. So we have surface mesh parameters and shell criteria and volume mesh parameters and volume criteria. Here in the size field for CFD meshing, we have added a new rule. Apart from the curve rule, we now have a leading edge point rule where the user can pick a point and specify the first and span-wise length of this anisotropic feature refinement. Moving on to surface wrapping, we now provide partial wrap functionality for model update. So you can imagine the scenario where we have created a complete surface wrapping of our model and we want to make a geometry modification in a local area. So, take for example this mirror. The user can merge in Answer new geometry and overlap it with the old one and place the old one in an Answer set. So this is what will be replaced. Then in the wrap function, we have a new button called partial wrap and the user needs to define here the ID of the set that will be replaced. In this case, the mirror. They can press Visualize and Answer will display a small octree that is locally constrained so as to wrap only that area of the new geometry. And upon pressing Run, Answer will delete the old part of the wrap, will wrap the new component and connect it conformally with the old surface wrap. Some other improvements in surface wrapping. In the past, when there was a gap between two panels and we used to create a wrap, we wouldn't maintain a straight edge because there was no feature to capture there. But now Answer will make sure that it creates a nice smooth PID boundary for the surface wrapping Octree entity. It is always recommended to have something meshed before wrapping it. And this can be done now very easily because once you set up your wrap Octree, you can right-click and create an STL batch mesh scenario. Answer will populate all the geometry in batch mesh with an STL ready-to-run scenario. So the user can just press Run in batch mesh and get something that is ready to be wrapped. We also provide a new option to delete the original geometry once the wrapping is complete. A new tool in the CFD ribbon is called Create Tire Plinth. In many cases you have a tire geometry which is intersecting with the road. The user can select these two and specify a plinth height, and Answer will create a small plinth to prepare the model for surface wrapping, or Hexstream volume meshing. Moving on to volume mesh, we have improvements in Hexstream. We have added an option for smooth iterations of the volume mesh near the layers area, a maximum aspect of the generated layers so that when it is reached, layers stop growing, and a minimum aspect of layers during squeezing. All these working together result in a much better mesh quality because the layers stop growing once they reach a specific aspect and the rest of the mesh is smoothed. Similar to surface wrapping, both the Hexstream entity can be selected with right-click to create an STL batch mesh scenario so that the geometry is meshed before actually performing the Hexstream meshing. Also in Hexstream, there's a new menu option called Connect to Symmetry. In the past, the symmetry plane may had some deviations where there were concave areas, but now with this option active, Hexstream mesh will pass exactly on, and the symmetry plane will be absolutely flat and all features will be captured. The user needs to specify the option Connect to Symmetry and specify in which direction of the y-axis the model is located, and of course have a symmetry boundary condition type on the symmetry plane in advance. This option can also be used on a full vehicle, not a half-symmetric one. If you activate this option, Answer will be instructed to only volume mesh half of the model. So you may want to do this if you don't want to create a cut plane and cut the model, or if you want to do a quick preview of the Hexstream meshing on half of the car to ensure that what you get is what you want. And another feature that is new in Answer version 25 in Hexstream is that we can now create conformal mesh interfaces on interior boundary conditions between different fluid volumes. For this to work, the interior surface mesh must be set to internal boundary condition type so that Answer recognizes it as an interior, and the option conformal mesh at internal bounds must be active. For structured-like mesh, we have a new function called Map Block function. This is something more advanced than the old map function, because this function can automatically detect the mappable volumes and can also create the surface mesh as well. So you can specify a target length, a minimum number of rows for your radiator, and then Answer will automatically detect the mappable volume and the user can select right-click and volume mesh it. For more complex geometries, there is the option Decompose Map Block, which gives you access to a new toolbar that allows the user to create some cuts and new geometry so as to split the volume into smaller mappable components that again can be volume meshed automatically. We have a new function called ThinMesher, which can be used on detected volumes and generate thin mesh automatically. Again, this functionality was available in the past with a user script function. Now it is located in the main GUI. Moving on to Hexablock, we have a new template for automatic 2D airfoil meshing. So the user needs only to have a flat face with a profile of the airfoil. The spacing on the airfoil must be prescribed in advance. The perimeter nodes must be clustered in advance using functions like spacing. And then the user activates the template airfoil 2D, and they need to specify which is the airfoil section, where is the trailing edge, and then the 4 boundaries of the domain. Then they only need to specify the layer parameters, the growth factor, first height, and steps. An answer will automatically create the 2D blocking. It will create the 2D boxes, it will create the surface mesh and the smoothing. So the user gets automatically a ready-to-run 2D structured mesh. This can also be output in a structured file format because it's created based on 2D Hexablock boxes. For 3D geometries, we have improved our Turbo template to account for cascade cases with inflow and outflow domain. So there is the option Cascade Analysis, not a rotational one. And the user can specify that there is also an inflow and an outflow domain. Specify which boundary relates to which PID, some details about the number of elements in the 3 directions, or maybe automatic based on curvature refinement. And then the user can select to specify the fluid properties and to generate the mesh and the smoothing. The result is again an automatic generation of the 3D structured topology of the boxes, the volume mesh and the smoothing process. There is now a new spacing option called Advanced, where the user can specify curvature refinement details, a minimum length, a maximum, a distortion angle, and then Answer will automatically generate the volume mesh based on these parameters. We have now introduced a new functionality for volume mesh where the user can identify elements, volume elements based on coordinates. These coordinates may be fed from a solver that indicates them as having an issue like a high velocity, high pressure, or bad quality. So the user can feed back into Answer the coordinates of these elements and then open the Auth Inspector, and Answer will identify them in the display. Now we're moving on to morphing. Under direct morphing, we have a new function to modify the radius of curvature of fillets. The user needs to specify the fillet area and the neighboring mesh to absorb the deformation. It's a new function called direct morphing fillet. There are 3 options to impose change on. Either we scale the radius, or we offset the radius, or we specify a target radius. This is applicable only to FE model mesh, not geometry at the moment, but you can, for example, apply this on an STL mesh in order to change the radius of curvature of this fillet on the A pillar. So you can see the change in curvature in this small animation. And this can become a parameter as well, so that it can be affected through the parameters window under the optimization task. Whenever we had to create a model with several morph parameters, in the past, Answer used to perform the morphing one by one sequentially. Now it can be more efficient by merging them under one morph block command. So you can have 14 morph box parameters under one morph block. And this implies that the morphing will take place in one step, therefore accelerating the process. Moving on now to our SPH solver, which is embedded into Answer. We have improvements like adaptive time step and the possibility to have moving inlets that follow the movement of rigid bodies. We have Python script support so that the user can set up and run an SPH simulation through Python scripting, not only through the GUI. We have added support of various point sensors such as velocity, force, and wetting sensors, so that the users can monitor these scalars through time. We support the calculation of COG sensors to track the center of gravity fluids in time. And we have a new interactive tool to fill volume before starting the simulation at a specific height or volume. Finally, moving on to Meta, as we mentioned at the beginning, we have redesigned the interface of both Answer and Meta so that it looks similar. So the same ribbon design is followed in Meta. Again, on the left, we have access to important lists, and the functions at the top, we have the quick access menu to make measurements, take snapshots, and so on. We give access to the database browser like in Answer, so in Meta also you can see all the contents of your Meta file, geometry, results, and course all the entities that you have created like cut planes, streamlines, ISO functions, and so on. In the old interface of Meta, for example, when you wanted to create a new cut plane, there were a lot of pull-down menus there. This has been simplified in the new GUI, where the user can create cut planes from the ribbon quickly, and once a cut plane is created, a new ribbon opens for cut planes so the user can perform all the actions from the ribbon. Similar also for other things like ISO functions, a separate ribbon, and streamlines flow paths. The old animation fringe toolbar has been moved to the results ribbon. And the old CFD post toolbar has become actually a new ribbon with all the tools that relate to CFD post-processing, like for example reading of multiple results through the template manager, creating the mirror model, or calculating forces, or plotting 2D plots of force versus distance, and so on. This completes this presentation of what's new in Answer and Meta for CFD in version 25. Thanks for watching.